Alright. Hey guys. It's pretty late at night. It's time for some coding. Woo! It's a gamer time right now. I look like I am being kidnapped, and I'm not, I swear. I'm just up at night because I felt like it. Also, computer scientists don't sleep, so I don't know what you're talking about. I also look pretty cool. Just got my gamer artist hand and pen to write stuff. I hope y'all enjoy, and I hope y'all understand. If you have any questions, just comment down below or ask me in person. So yeah, this was the meet we did on Tuesday, but this wasn't like official. This was just like practice. Anyways, that was some like Chinese drink. So let's do this problem. Okay, so this is one of those basis questions, and it's usually first. Why is that scooted? What the hell? Okay, yeah, I think it's fine. But with bases, usually you want to convert everything into base 10. It's just easier. So in order to do that, how to convert a number to base 10 is by doing the following. So it starts off as the base to the power of 0, and then it adds by 1 slowly as you go left. And bases deal with digits, just as like in base 10, if we were to add all the way to 10, right? Notice how there's like another new digit. Well, if I were like in base 8, right, I would count all the way till 7, and then 8 would be a new digit. That's how bases kind of work, if that starts to make sense. So in order to convert a number from a certain base to base 10, we'll lay out all the exponents and then multiply the top times bottom. So 1 times 2 to the 4th is 16. And then 0 times blah, blah, blah doesn't matter. 1 times 2 to the 1st is 2. So we get a total of 18 for this first one. So for the second one, it's very similar. We just lay it all out. So 16, right? This is 16 to the power 0, 16 to the power 1. 4 times the 16 to the power 1, which is 16, is 64. And 6 times 16 to the power 0, this is 1. So 6 times 1 is 6. We get a 70. And then our total for the sum of these two is 88. So now we just gotta convert all of these and see if it fits. Well, this one's already in base 10, and we know 88 is not 89, so that doesn't work. Same idea here. What we're gonna do is we're gonna do this. Okay. 1 times 8 squared, which is 64. 1 times 64 is 64. 3 times 8 to the power of 1, which is just 8, is 24. And we get a total of 88. 3 times 8 to the power of 1 is 24. Okay, yeah. 88. It's B. I'm going to check my work, just in case if I made a mistake. So here, here's like a quick note. We know that the number is even, right? And this is odd. How do I know that? Well, for every base number, like if I had this first digit on the very right is going to tell me whether it's even or odd. Because if you notice, like no matter what number it is, whether it's like 12 to the power of 0 or 16 to the power of 0, this equals to 1. So it's this number times 1, and that's going to be added to your final number. Does that make sense? So a handy trick is like, oh, okay, 1 times 1, we know the rightmost digit is always going to be 1, is always going to end up as an even number. I know this number is even because it's binary, and this is by powers of 2, and stuff like that. And like TLDR, if the last number is an odd number and the base is odd, that means this guy is probably odd. Okay, now that's just a trick. If you want to check, I'll actually like write it out and do the math. This is 1, 2, 4, 8, 16, 32, 64. 64 plus these two make 24. I'm speedrunning this, by the way, and it makes 89, which is not right. Okay. let's try 73. 12 to the power 0 is 1, 12 to the power 1 is 12. 84 plus 3, this is 87. And then finally 56, 16, and then 1, 6 plus 80, this is 86, and final answer is B. B. So that's the first problem. It's probably going to be one of the longest problems, but it's fine, because that's usually how it goes. The first problem is pretty long. So what is the output of the code to the right? Okay, so this is postfix and prefix. So every time it has a plus plus before it, it's called prefix, meaning the number gets added first, then it goes into the equation. And then if it's postfix, it still gets added, but it's after using the equation, or after it's being used. So what I mean by that is, for example here, A and B start as 5 and 6. And usually if it was just like A plus plus, right, A would just turn to 6. Make sense? However, since, so just to be clear, by itself, with nothing attached to it, these two mean the same thing. However, since we're using like an equation here, or we're doing assignment with the equal sign, it actually kind of changes. So what it's actually going to do is it's going to say, okay, this is, A is actually 5 currently, right? Plus B, which is actually going to be 6 plus 1. Because the plus plus comes before the variable name, that means the plus 1 is added. Since it comes after for A, it's not added. So in total, C would be 12. However, note that after everything's done, A finally becomes 6. So when you're doing the println, it's going to be 6 minus 7 plus 12, which is going to be 11. Now, yes, if you remember, A++ changes the number and increases by 1. And it's the same thing as this, except just remember, if it comes before, that means if it's in an equation or like in a line of code, that means it changes. We do the changed one, and then if it's after, we don't do the changed one. Or we don't make the change. Say A. Ta-da. What is the code to the right? Okay. So how it works is like this. So we got a string, char array of C, and it already declares it right here. So technically we can just declare variables like this, right? So it's not a syntax error. And let's see. So remember, arrays start at 0, so 0, 1, 2, 0, 0, 1, 2. So we know that C at array index 2 is referring to this. And it's checking whether it's equal to the char at index 3. So P0, 1, 2, 3. And it is equal because they're both characters in C, so it should be true. B. Yes. So notice true and false are in like lowercase, so keep that in mind. Okay. Next one. Okay, this one's kind of annoying. So these are already declared, so let's go to this line. Substring 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So when you do substring, it includes the first value, but it doesn't include the second value, if you have a second value. If it doesn't have a second value, it goes to the end. So this first part is going to be Gabi. D at char at 3 is 0, 1, 2, 3. So it's going to be Gabi. So when you're adding a char to a string, it just adds this char straight up. E plus C substring 2, 10. So 1 or 2, 3, 4, 5, 6, 7, 8, 9, 10. Right here. It's going to grab that. Oh, actually, it doesn't grab the P because it doesn't grab that second number. So you grab all the way up to 9, actually, instead of 10. So E is going to add to the very end of it L space the space S. And it's going to add char at 7. 0, 1, 2, 3, 4, 5, 6, 7. So it's going to add that T at the end. And then this replace command does is replaces all the spaces with whatever this is. So it replaces whatever string with another string. So it's going to replace all the spaces with a dash. And we'll get to Gabriel the B. Because there's no space at the beginning, these two are wrong, and there's no syntax errors, so yeah, we're good. So it's B. Nice. Okay, what is the code to the right? Okay, so how the order goes is AND comes first, then XOR, and then OR. These are called XOR, these little carrots. So I had a question, what was XOR? So I'll go over that. So kind of how it goes, just like this. So T starts off as false and F starts as true. Great. So these have order with precedent. You can check the UIL study guide for like making sure you don't do anything stupid. I just use Miss Windows website. She makes good stuff. The great UI study guide. So how the order goes is it's AND, XOR, and OR. Same thing with the conditionals. Actually, oh, well the bitwise actually goes first. Huh. Okay. I didn't know that. Well, I learned something new. So this guy comes first, then it comes to this guy, and then it's this guy. So I'm actually wrong. Yes, you will have to memorize it. It's okay. Don't worry. I think it's stupid, but it's okay. You can get a lot of points from it, so you kind of have to do it. It's a necessary evil. So let's kind of fill this out. It's going to be true or false, and true XOR F, or this is false, XOR false. Okay, wow. Okay, so this is what we're doing. So the carrots come first. So if the two values, the two Boolean values are opposite, that means it returns true. Okay. If they are the same, that means it's false. That's how I remember it. So these capital letters represent true or false, not the variable names, by the way, because the variable names are so greatly named. So let's go left to right, and we know XOR comes first. Yeah. So TF, T XOR F, well, they're different, so it returns true. T XOR F, I'm grabbing this guy here. So this becomes true, and then that becomes that. T XOR F is also true, so good. Let's bring everything down. And then we know that AND comes before OR. So F and T, well, and how AND works is if there is a false, no matter what, or, if there is a false, that means it returns false. That's how it works. And for ANDs, both of them have to be true in order to be true. So for example, like the if statement would be if my first name is David and my last name is Zhang, that means I am David Zhang. So it's like both of them have to happen. So this returns a false, and then how OR works is as long as one of them is true, that means it's true. So the answer should be, wait, I think the answer is false, if I remember correctly. What did I do wrong? Oh, wait, I forgot. Yes, IDK does return true, but it does a debate on you, and it does that. So F is true, so true XOR true, since they are the same, that means it returns false. I almost messed up there. It's false. Yes. Math works. Yes. So how to remember? Just a quick formula. It's okay, guys. This was a very fun question because you have to memorize it. Because why? So how it works is anything with one character comes first. Actually, I'm going to show you. Anything with one character comes first, and then the order is the same. So it's and, XOR, or, and then and, or. So and always comes in front of or. That's it. That's a good way to remember. OBS is working fine. Cool. What is the opposite to the right? Okay. Math.4. So what you can do here is you can scroll up and find math. And floor returns a double. Therefore, it prints out a double. 6. The number in here is 6 if you can't tell. Not A, but it returns a double. Also, how floor works is if I had like 6.7, it just rounds down no matter what, so it's going to be 6. That's how it works. If it said math.ceil, like ceiling, it would round up no matter what. So if I had like 6.1, it's going to round up to 7. It's going to be 7.0 too. That's kind of how floor and ceiling work. Okay. The next one. What is the output of the code to the right? Okay, so integers are 32-bit. They're 32-bit. And 8 bits are 1 byte. Shorts are, I think they are 16-bit. So if you convert these, it's going to be 4 bytes. There's 2 bytes. And that's 16 or 6. Funny enough, yeah, you kind of have to memorize these. I think it's in the study guide actually. I'm gonna pull up the study guide. Yeah, there. Bytes are 8, 16, or shorts. But yeah. So notice how double is 64-bit. Okay. So yeah, 6. What is the output to the right? So let's see. This should be easy. 5 is less than 7, so it's going to print out A. Else if, well, the else if is not going to run, so because the if statement will run. And then now we have a new set right here. If A minus B is less than 0, which is true, because 5 minus 7 is -2. Print out C, so the else if statement doesn't run. And then this E is not part of it, so we just put the E in. I don't see there could be a syntax error, but it's B. What is the output of the code to the right? Okay, this one's kind of annoying. This is probably one of the reasons why I didn't finish the test, because I took so long on this problem. So how it kind of works, let's just like set J to 1. And J equals to, notice how it's plus equals to, so it's going to be whatever the number before is, plus 1 plus 1 plus y is currently 0. So J becomes 2. Okay, that's one iteration. Now y is 1. So basically what I'm doing is just writing it out. 2 plus 2 plus 1, that's 5. You'll notice the pattern is just like 2x plus 1. 11, or actually 2x plus 2, because y increases as well. So it's 24 plus 3. And we'll have to do this a bunch of times. 58, 116 plus 5, 121, 242 plus 6, 248, 2, 4, or 5, I'm doing the math in my head. 496 plus 7, and that is 503. So I stop at 7 because once I reach 8, remember this represents the y value. Once I reach 8, 8 is not less than or equal to 8, so the for loop doesn't continue. Yeah. 9 is D. Yeah. So kind of how for loops work is you gotta write out a lot, and you'll notice like a pattern quick, and so just like keep on doing that pattern. These are like essentially wasting your time, or ways to waste your time, so you gotta watch that out. I would suggest doing these problems last, but yeah. What was the opposite of the code to the right? So yeah, this is actually legal, so you can actually do that. You won't get an error. So a trick to do this is you don't have to like rewrite the whole array. What you can do is you can just a to the 2, or a index 2 is referring to this index, which is a4. And then a3 is referring to this index, which is a0. So yeah, this is a new integer. So what we'll do is we'll grab a4, which is 0, 1, 0, 1, 2, 3, 4, 5 plus, I don't know why I wrote it on there, a0, which is the first line, and it'll be 6. B, nice. Mic working, everything good? Okay, cool. Okay, that should help balance in my face. It's also very late at night, so my brain is at a 0. So, okay, exceptions. So first things first, Java is very restrictive. They love putting exceptions because they are like that. In C++ they don't do this, but every time you want to scan a file, it's going to print out a file not found exception, okay? Because there's a possibility that the file you return here does not exist. And Java wants to prevent that, and yeah. So in order to do that, in order to like still use a scanner, you have to throw it. Or you like what throwing does is you're expecting an exception. You're expecting a error. Exception and error is like practically interchangeable. So what's going on is technically IO exception is like a superclass to file not found exception. An exception is a superclass to IO exception. Okay, so basically exception refers to every exception is in existence. So if I throw exception, that means I know there's going to be something wrong. I just don't know what the exception is. If I throw IO exception, it is going to throw an input-output exception, meaning like I am expecting that an input-output exception is going to happen. So even though the exception will pass, or even though Java will see like, oh, this is an exception, it's still going to run the code. Okay, like that. So let me re-explain. So what throwing does is you're expecting an error, and then after that, you're letting the code run despite knowing there's an error. That's what throwing does. You can put it right here. Okay. There's also like try and catch statements, but we'll talk about that later. So exception, if I just throws exception, that means I throw every exception. Like every exception in existence, I know that it's going to happen. Okay, and if an error pops up, Java's going to still keep on running despite, like, you know how when you code and an exception pops up, like index out of bounds, it just stops the compiler? Well, if you throw the exception, that means it's still going to continue. Throwing IO exception specifically throws input-output exceptions. Okay, and then file not found is specifically the file not found. So actually this refers to a file not found exception because Java doesn't know whether this a plus com.sci file exists or not. So the answer is all of the above. If you want to know more about exceptions, you can probably like learn it. You'll probably learn it in like comp.sci data structures, but it's fine. Just remember that here you usually write throws IO exception. Yeah. Just yeah, it's kind of hard to explain, but exception refers to every exception in existence, and then IO exception refers to input and output. File not found is a file is possibly not found, and that's what this actually returns. The output of the code. So this one's kind of interesting. So let's keep track of y. So y starts at 0, so let's just pick it out, yay. Then it's going to be equal to 0 plus 0 plus 1, so notice how I add 0 twice. That's how iterations work. So y is now going to be 1. Let's grab 1, so that's b. And then we're going to do another iteration, so it's 1 plus 1 plus 1, and that's 3. 0, 1, 2, 3, so d. And then if I do it again, so 3 plus 1, 7, 0, 1, 2, 3, 4, 5, 6, 7. And then it's going to be b if you do it one more time. So if it's 7 plus 1 is 15, and you should get p as the answer. Yeah, so this one's just like writing it out and not doing anything dumb. Here, again, this is order of operations. So AND comes first, then there's XOR. Actually, wait. First things first. Any math comes first. So multiplication comes before addition, so we'll do that first. So this becomes 24. This becomes 13. So what ends up happening is 5, 24, 13. And also comes before XOR. So in order to do this, we have to convert the numbers into binary. So in order to do that in order to convert numbers to binary, what is the highest power of 2 that is under 24? And the answer for that would be 16. Or what we'll do is we'll subtract 16 out of 24. That's 8. Okay, so this represents 2 to the power of 4. Okay, now we go down from there. Can we fit it 2 to the power of 3? Yes, we can. We get 0. Can we fit it 2 to the power of 2? No, 0 can't fit that. 2 to the power of 1? No. And then 2 to the power of 0? No. That's how we convert it. So this is 24 in base 2. For 13, let's convert it to base 2. What's the highest power of 2 that it can fit? Well, it's 8. So 13 minus 8 is 5. So this represents that. Can I fit to the 2 to the power of 2? Yes. Let's subtract it. Can I fit it to the power of 1? No. Can I fit it 2 to the power of 0? Yes. So eventually what it lines up to be is this guy. I'll erase everything extra. I'm going to take my horse to the town road. Okay, so now how AND works, let's erase this. Actually, let's just write over here. How AND works is kind of like how Booleans work. If 1 is the true value and 0 is the false value, right? If I were to do AND, it's kind of like addition, so anything after would be 0. Like any empty space is going to be 0. It's kind of like addition, so you go top to bottom. So 0, 1. What is 0 and 1? That's 0. Because like if you think of this as false, right? False and true is false. That's how we get it here. False and false is false. This is false. And then notice how these two ones, true and true, that also makes true, so we're going to put a 1 there. And then in order to convert it back, we convert this back to decimals. So 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, and this ends up being 8. Okay, we still have to XOR it by 5. And in order to do that, we have to convert it to binary again. I have to delete all this every time, this is so slow. There we go. I try to control A delete, but that's not a thing in this, I guess. Okay, so we have to do this and convert to binary again. I'm just gonna do it real quick. Fill up any empty spaces with zeros, and then this is how it goes. So what we do is, if the two numbers are different, that means it's a 1. If they're the same, it's 0. Convert that into binary, or to decimals, we get to the power 0. So that's 8 plus 4 plus 1, and we get 13. That's how 13 works. This one you kind of just have to know. Usually for these, it's probably not going to be none of the above. I've never seen a test say none of the above. Kind of hints you can do is like, I know that this one is, what is it, D? Oh, D? Interesting. I know that like usually these two guys, since they both have like equal signs, they're around the same area. And oh wait, they're not in the solution, huh? Oh wait. So what you can do is, usually like any math comes first, so that's why 1 is the solution. Then I don't know, it's just like kind of memorizing. There's not really much to do with it. I mean, we got this if you want to look at it. Just remember that accessing an array is actually pretty high up there. Multiplication, then there's assignment. Oh wait, no, there's bitwise OR. Yeah. So usually these bitwise come from like pretty high up as well. Yeah. Any assignment comes last. Oh, I didn't know that. Okay, so yeah. Any assignment comes last. It's just like these little like memorization techniques. That's kind of how you do it. It's kind of hard to remember sometimes. So here you're just making an array list and you're adding 3 to it. So kind of just imagine this. And what set does is it changes the value. So what it becomes 4, but there's no syntax error. But you return the value that you changed. So I changed my 3 to a 4. So I print out 3. So the replaced value, that's what you output. Fun zone, here it's just like, you notice how it's a double, so you have to return double. So J is 7, so 7, G starts out as 3. G multiplied by J, so G is now 21. You can multiply doubles by ints. And then divided by 2, and you'll get 10.5. This was pretty easy. Okay, what is the output of the code to the right? Okay, this one is kind of annoying. First things first, you'll notice that G is also added here. So if this wasn't here, it would actually just be 7 times 6. Because G++ runs as long as like a for loop's running. So every iteration G is added. So this has 7 iterations, right? 0, 1, 2, 3, 4, 5, 6. Those are all the numbers less than 7, and they start with 0. So G increases by 7. And then here, this G increases by 6 minus Y. So what I did was, I did it like this. So this is what I did. So let's start with Y. So Y is 0, so G is added by 1. And then the amount of numbers between 6 and 0 is 6. Or, yeah. So there's 6 numbers, so I add 6. Because that's how many times G is going to be added. And then for Y is 1, or, yeah. So this is Y equals 0. For Y is 1, it'll be 1, because G gets added once here. Plus 5, because this is Y, so H is 1. And there are 5 numbers that are less than 6 and start with 1. So yeah, and then you'll see a pattern. Or wait, this is 3. Oh dang, this is gonna take a while. So the pattern here is there's 7 ones, plus 6, plus 5, plus 4, plus 3, plus 2, plus 1. And then you'll eventually have a 0 because this can go up to 6. Y can go up to 6, and 6 is not less than or equal to 6. So adding all of them up would equal to 13, 9, 6, 28. And that's A. These are kind of hard to gather, but the more you do for loops, the better. Here was actually kind of a rough one for me. So what I like to do with these is multiply these, right? So if it was O of n time, right, if I multiply this by 2, that means it would take 2 times the amount, right? So if I had 2,000 numbers and I want to check how much 4,000 numbers made, there is a 2 times increase in the value of n, therefore there must be a 2 times increase in the value of seconds. So it's kind of like this. O of n times 2 is 2 O of n. Something like that. I don't know. So I was like, okay, that doesn't work. Linear doesn't work because, like, it's taking a lot of time. O of 1 doesn't work because if it was O of 1, that means like all the seconds would be the same. There's no rate of change. So if you think of like time complexity, think of like a graph. O of 1 would be like this, where everything is equal to x equals to 1. O of n would be like a linear graph, right? The more stuff you have, the more time it's going to take, right? If I had like O of n squared, like that, yeah. But when you're doing time complexity, also, you can't have any coefficients, so it can't be like 1/2 over n. So now it leads to these two. So O of log n is kind of a little weird, but what it does is it's just n times log base 2 of n. And this log base 2 can increase by a little bit, but not too big. So kind of, this can't be n squared because if 2,000 times 2,000, so if you think of it as like a thing and you replace n with 2,000, right, and it gets somehow 1 second, you would expect like this would be, this is 4 million, this would be 16 million, right? You would expect a, no. I don't know, but it's just like if you, or yeah. So if I did n squared, right, this would be 4 million. And this would be 16 million. So there's a 4 times increase, which does match the first one. But if I did 16 squared, that's like 196. 1, 2, 3, 1, 2, 3. And then the square of this is 16 times, which doesn't match this. This is 8 times, so it doesn't match. So yeah. O of log n is kind of hard to calculate because you can't calculate logarithms immediately, but it should be like, if anything else doesn't work, it should be log n. Yeah. So here, double is capital, meaning it is a wrapper class. So just like an array list, you slap the capital in it. It's now an object rather than a primitive data type. Primitives are like ints. And because it's an object, it has to be whatever it is. It can't like change. So I can't use an integer for a double. It has to be a double. So if there's a capital sign, it has to, like any assignment has to relate directly to it. So I can't have an integer when I have like a capital D double. That makes sense. 20, how this guy works is, if not for those meddling kids, so what we'll do is, this is called a regular expression, and there's different parts, regex. So these are like, imagine like a basket full of characters, and every time you see the character, you can separate it. So, so if you know like split, right? Split, what it does is, if you've ever used split, I did like if not, and this is a space. If I split it, what it does is it makes a string array, and then it divides everything by whatever string you put in it. So if I did split, s.split empty like a space, it's going to split by space. So the string array made after split is going to be if not an A. Got it? And there's no space in between. That's kind of what split does. Now if you had a regex in it, if it follows the regex, that means it splits with it. So kind of what's going to go on here is, just watch. So if you see these brackets, it's going to work. So yeah, I'll just start explaining it. So first off, we see a space, which is in the brackets, so it's part of the thing. So anything before it is going to be its own group. So if. And then this space will be x'd out. N is also part of it. O is part of it. But T is not part of it. So we'll slap a T in there. Now, this 1 to 6 tells us that we can use these letters 1 to 6 amount of times. Okay. So this space NOT, or this space NO, there are 3 characters. So it fits within 1 to 6 characters, if that makes sense. Okay. Now here, there's a space. We don't want the space, that's 1. F is not in our little dictionary or basket, so we can put it in. O is in it, R is also in it, and the space is in it. So this is 3 characters, so we don't have to worry about exceeding 1 to 6. TH, and then OSE is part of the regex, and the space is also part of the regex. M is not part of the regex, so we'll take that out. E is, and then D, D, L, I, N, G. There's a space. K is part of this little basket. I is not part of it. And then D, S is not part of it as well. So, yeah, moral of the story, regexes help divide strings, right? And if you see like square brackets, that means anything inside the square brackets is like in a basket, and every time you meet it, you can, if they call split, they divide it. That's kind of how it works. 1 to 6 means if you see any one of these numbers in the basket 1 to 6 times, that means we can cross it out together. So notice how like this was in a group because space, N, and O were all part of it. It's kind of hard to understand. You can do some research on regexes yourself. And total, the third number would have been TH, and the length would have been 8. Yeah. So here's kind of interesting. Me and Sam both got this wrong. I'm drinking like Chinese energy drinks. They're not energy drinks at all, they're just like kids' drinks. So this is one of those inheritance questions where a class inherits another class. And it can get really confusing. So first things first, because there's no like public, private, or something like that, this automatically defaults to public. So that means any class outside of it can access this A, or can access this A directly. Also, if a class extends another class, that means it gets all of its attributes. It gets all of its attributes and it's like all the details from its constructor. So what it does, it gets everything, and then if you want to change anything, like the inc function, it does that for you. Or you can change it. That's how inheritance works. So it asks, how do you add 2 to instance variable A? Well, since we have direct access to it, not only because it's public, because if it's public, we can extend it and grab it and inherit it. Since it's public, we can use every single one of these. When you call super, so class A, class B, so B is inheriting from class A, and A, the one above, is called the superclass, and this is called the subclass. So what super does is it allows you to grab stuff from the superclass, like directly. So like instead of calling this inc function, it's going to call super.inc, which is going to be the superclass's increasing function. That's why. Remember, because A is public or defaulted to public, that's why you can grab A like this. Okay, so now what is the output here? This is just asking what does it print out here. So follow on. So how this works is like this. So what is the output of the code? Okay, let's look at our constructor. Constructor just adds 5. A.inc adds 1. That's 1. And then print it out. So it's 6. Easy enough. Now I got this. A7. So now we have a parameter. That means we add A to 7. Now here's the deal. Because A is static, okay, all the A's are connected. Meaning that if you called A.A, so what dot does it like prints out the value A. Or like if I were to call system.out.print A.A, it's gonna print out this value. Got it. So what dot does it prints out like an attribute or a method. Okay. And back to static. So because the variable is static, that means all of its numbers are shared. So this 6, even though it's a completely different object, since they both come from the same A class, that means they are both affected. So when it says A plus Y or A plus 7, instead of A.A being 7, it's actually going to be 13, because remember 6 is from here. A.inc, we add 1, and then we make a B. So B actually inherits the constructor, so it adds 5, making it 19. And not only because the variable is static, that means the plus 5 also affects the A as well. So if we call B.A, it's going to be 19. E and B. Here gets even better, so we inc, and since it's B.inc, class B, that means it increases twice right here. That's 2. So it's going to be 21. Integer C, so C saves as 21. And then A.inc, it's going to be 22. Right, but since it's saved to an integer, that means we only print out 21. Alright. So here, this is kind of like reading into kind of how for loops work. And you'll notice that count starts as 2. So that's like 2 to the power of 1. And then x is undetermined. And then this for loop runs x times. Okay, we know that because, we know that because if, like, a for loop starts with 0, and it's less than x, it's less than, keyword less than, that means it runs this amount of times. That's just, like, kind of common knowledge. For example, if x was 4, right, let's name all the numbers starting from 0 that are less than 4. And there are 4 numbers. It runs 4 times. So yeah, so this for loop is going to run n times, meaning that 2 is going to be multiplied x times. And we already start out with 2. So mathematically, it's going to be 2 to the power of x plus 1. Okay, here, sorry. Today. So when you're doing constructors, this angle bracket does not matter. You do not add it, no matter what. Yes, A. You do not matter, or add it no matter what. Yeah. So here, this structure is very similar to a queue. If you've ever learned queues, whether from me or from YouTube, queues are kind of like a movie theater. So if you're going into a movie theater, right, the first or it's like a lunch line actually, and it's like first come first serve. So like they enter the queue first, that means they leave the queue first. If that makes sense. So just like watch, right? So I'm adding 986, so 986, right? And then, let's see, it says star remove, so we can look at a remove. And the current start starts out as 0, index 0. This is kind of like our array. And the current end is 0. Or actually, the current end is 3, because we add it. The current end is added. So the current start is added by 1. And then it returns 9, or returns whatever was before it, so it returns 9. And then, yeah. sc.add 10. So we add 10 to the back. We remove it, so it's going to take out 8. And then add 3. And then print it out, so it's 6, 10, 3. So if, let's be right, yeah, AB. So with these problems, the main difficulty is trying to understand what's going on here, because it's like kind of hard to read. So like first things first, it has a toString, so when you're printing it out, it's going to print out the toString. And it goes from the start to the end variable. And what it's doing is it's creating an array, right? And oh, what the hell? Weird. Okay. Did like my computer crash now? So it's creating an array, and so every time you're adding it, let's say like you're adding, or actually, if it can't fit, it's creating like a static array, or like an array of a fixed size. So, for example, if the end is equal to the context length, so the length of the context is right now 0. So it says end equals to 0, so we'll resize, and it will be current end times 2, contents, blah, blah, blah. Wait. Oh wait, content size is 1. Okay. So it makes it empty. So I think it would just be like null or something. Then, yeah, so we'll double it. And kind of, it's like an ever-expanding array. If you've ever heard of a dynamic array, this is very similar to it, except when you're removing, you're removing from the start rather than the end. This kind of just takes practice, and the more algorithmic stuff you do in the future, that's kind of like better at reading this. Yeah. What is the output of Q29? Okay. So this is in a kind of a 2D array. So what we'll have to do is we'll have to rearrange it. So 0, 2, so row 0, column 2, 7, is now 4, 0. 0, 1, 2, 3, 4. So this 7 becomes a 17. Okay, we're done with this one. Row 1 is equal to row 3. So we're going to change this to row 3. Check. 0, 1, 2, 3, 1 is equal to 1, 0. So 1, 0. So this actually becomes 2, 1, 2. Check. 2 equals to 4. I'm going to straight up just equal it out. 90. Check. 0, 0 equals to 1, 1. 0, 0 equals 1, 1. So this changes to a 0. Okay, 29. Print out 0, 1. It's a 3. Q3, print out 2, 2. 0, 1, 2. 0, 1, 2. And that's a 90. Should be A and D. Cool. That's kind of how it works. If you're equaling out rows, it actually changes the size, which is pretty cool. What is Q31? Okay, so raised as toString mat 3. 0, 1, 2, 3. So it just puts out 2, 1, 2, or 2, 1, 2, and 2, 1, 2. It's A. Coolio. Okay, so this is kind of where we can use like dynamic programming. This sounds fancy, but what we're doing is kind of making things a lot easier. You could just do like recursion and stuff like that and make like a tree, but here's like an easy route. So yeah, so if I called Coolio, this is like let's just change this to F because I like writing F. So if I called F of 0, it's going to return 1 because of this if statement. If I called F of 1, it's going to call 1 plus 1 is H plus F of 0 plus F of minus 1. No, they're going down here. And we know F of 0 is 1, and then we know F of minus 1 is going to be 1 as well because it's less than 0. So it's going to be 1 plus the 2 before it, which is 3. 2. It's going to be 2 plus the 2 before it because 2 minus 1 is 1, so F of 1 is 3. 2 minus 2 is 0, and then yeah, so it's going to be 6. 3 would be the 2 minus plus that, so 12. 2 minus would be 18 plus 4, which would be 22. 2 before it, 34. I'm running out of room. 34 plus 22 is 56. 56 plus 34 is 97. Crap, I forgot to add 5. Cringe, cringe, cringe. Ugh. Okay. Well, I'm pretty sure the answer was like 310. Actually, let's just like go on. I don't want to get the answer. This is 61 plus 6 is 67. 67 plus 39 plus 7 is 106, 113. This plus this is 180 plus 8 is 188. And finally, we have this plus this, which is 304 plus 9 is 313. What? Wait a sec. Oh wait, this is 198. So this plus this. Ugh, math in my head. Also at 2 a.m. 311 is 311 plus 39 is... I think I did something wrong. Damn. Is it 310? It is 310. God. Okay, let's do it right. Let's just do it right. Just do it right. Ugh. This is why you never make videos at 2 a.m. You did not do this at 3 a.m. No way. Okay. So 0, 1, 1 is going to be 3 because -1 is 1. Okay, continue on. This is 6. Adding the 2 before plus the current. That's what's going on. 18 plus 4 is 22. 5. Adding these two is 34 plus 5 is 39. 6 adding these two before is 61 plus 6 is 67. 2 before is 103 plus 7 is 110. Yes. 8 adding the 2 before is 177 plus 8, so it's 185. 9 adding to the 2 before. 295 plus 9 is 304. Bruh. Wait, this does not equal to 110. What the heck? 106 plus 7 is 113. adding the 2 before, we get 190, or 180 plus 8 is 188. 9, add the 2 before. I think I'm doing the math wrong. 1, add the 9, that's 310. Okay, there we go. That took a little bit. Output the code to the right. Okay, so here's the deal. This is private, this is public. It also extends it. So, yes, it is valid that you can have like a separate poo variable, but here's the deal. Blue, this is a blue variable, and it's calling the purple constructor because it's allowed to. So this is kind of how the map looks like, right? Any superclass can call subclass functions, right? Any blue can be a purple, right? But not every purple can be a blue, or something like that. I don't know. Wait, no. Every purple is a mixture of blue. It's weird. Anyways, so basically this is a blue variable. This first guy is going to tell us what it is. Then the constructor is going to tell us what to do. Okay. Now it's still a blue variable, but it still can call the purple constructor. Okay. Since it's still a blue variable, I cannot access my poo variable because it's private. That's why it's going to give a compiler. That's it. Which of the following will replace that? Columns. So you can't have parentheses for arrays. So this guy. Also keep in mind that if you want to get rows, it's just dot length, and then if you want to get the columns, it's this. You have to add that to it. Assuming that lights is filled correctly, what method lights return assuming the following matrix is passed to mat? Okay, well, let's check it out. So start is equal to max rows and columns. So the max of these is 3 minus 1, so it's 2. M is equal to start divided by 2, which would be 1. So start starts at 2, and then it's greater than blah, blah, blah. And then, yeah. So first tote would be equal to, or it starts with 0. So I is equal to start, so it's 2m. So 2, 0, 1, 2, and then m is 1. So it's 5 plus 1, 2, which would be 6. Which would be 1. Then start decreases, so looks like m doesn't change. This just adds 1, 1, 2 times, right? So it's 9 plus 9. We get 18, 29. And then start equals to 0. So 0, 1, 0, 1, and then 1, 0. We will get 32b. There we go. Yeah, so that one may take a little bit of time, but it's not too bad at all. Okay, so first things first. Next character doesn't exist. So what scanner can do is if you put in a string inside of it, you can, or actually, yeah, if you put in a string inside of it, you can like scan it as if it was like a file, or if it was in your like terminal. Okay. So what you can do with scanner is you can check what type it has next. So it's like has next double, or any has next is going to return true if it has, like for example, has next int. It's going to return true if it sees an int, and it's going to return false if there's no int or no integer. So like if it was a string in the input, okay, it would return false. Kind of make sense? So right now here, we notice that the code is calling next, so we can just ask call has next, right? Because it's looking for a string or a next. That makes sense. If this was filled correctly, what's the purpose of the method mystery? So notice how we're only checking the first character. That's it. And we're also checking X with a bunch of vowels. So that means we're just checking the first, or whether the first character starts with a vowel, so to speak. Okay, so binary trees. How long is this? Wow, it's an hour long. So, binary trees. So basically how binary trees work is if it's greater, so you start with like the first number. So you just move right to left. If it's greater, you put it on the right. If it's less than, you put it on the left. So is 1 less than 3? Yes. So we put it less. 45, you put it to the right because it's greater. And then what you do is you start from the top. So is 67 greater than 3? Yes. Okay, we're going to move it to the right. Is it greater than 45? Yes, we're going to move it to the right. That's how we play stuff. We just start from the top and then move down. 3. Is 23 greater than 3? Yes. Is 23 greater than 45? No. So we're going to move to the left. 2. Is it greater than 3? No. Is it greater than 1? Yes. Is it greater than 3? No. Or yes. Is it greater than 45? Yes. Greater than 67? Yes. 90 is greater than that. 212. Is it greater than 3? Yes. 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 No. And then is negative 3 greater than 1? No. So it moves here. Is 17 greater than 3? Yes. Is it greater than 45? No. Is it greater than 23? No. Okay. So how do you find, 0. Greater than 3? No. Is it greater than 1? No. Is it greater than that? Yes. That's how you put a tree. This is a binary tree. So binary trees have 2 edges, just like in a graph. That's why it's a tree. So yeah. So what is the height? Well, the height is the amount of lines, actually. It's not, so the height would be 1, 2, 3, 4. Or you can call this first top node is going to be 0, and this is going to be 1, this is going to be 2, this is going to be 3, this is going to be 4. You can do that as well. How post-order traversal is all the children go first. So you start from the left and then you move up. So it's like, hey. So you move down to the left, the very leftmost node, which would be 0, because it's the lowest. Then it goes up. It asks, okay, does negative 3 have any children that we haven't met yet? No, so we use it. Does 1 have any children that we haven't met yet? Yes, we have 2. Does 2 have any children we haven't met yet? No. And then does 1 have any children left? No. Does 3 have any children left? Yes. Does 45 have any children left? If there are 2 choices, if we can move left or right, we always go left. Is there a 23? Does 23 have any children? No. Or yes. Does 17 have any children? No. Then it moves up to 23. Does 45 have any children? Yes. 67? Yes. 90? Yes. 212? No. 90? No. 67? No. 45? No. And then 3. Finally, no. So yeah, I'm going to quickly compare this. So I did this right. 0, negative 3, 2, 1, 17, 23, 2 and 2, 90, 67, 45, and then I think there's a 3 at the end. 3. Okay, so now how in-order traversal works is all the numbers are in order. Okay, that's kind of quirky. You just sort the darn thing, so it's just this. You just sort the array. Or blah, I didn't even sort it correctly. There's a 2 as well. Next one will be 17, 23, 45, 67, 90, and 212. So yeah, it is sorted. In order is sorted. There's also pre-order as well, but I'll explain that later. So yeah, I did it in an hour. Whoopee! Let's go. I hopefully y'all understood. Went through a whole test. Hopefully I get better. Hopefully we make them rats. I hope you had fun. It is also very late, and my parents are going to yell at me, but it's okay, because it's all for the grind. You know what I'm saying? I'm so tired. But have a great day, and I hope you enjoy it.